Manifold Edge is a cloud-based service accessible from most popular web browsers. We will demonstrate how MD tools and related work products can easily be shared with those who are invited to inspect and interrogate the manifold design. Also note that all content either uploaded to or created within Manifold Edge is secure and accessible only to those collaborators who are invited to participate or to view. We will show an abbreviated Manifold Edge workflow focused around 3 fictitious companies. Oily Hydraulics designs, machines, and assembles hydraulic manifolds. They subscribe to the Manifold Edge service and have been longtime MD Tools users. Carlo and Mark are both experienced manifold designers. Carlo is proficient with MD Tools, whereas Mark is less familiar with MD Tools in his design review role. GT&R Excavator Incorporated designs, manufactures, and sells excavators. GT&R recently issued a purchase order to Oily Hydraulics for design and manufacture of a manifold to be integrated on their new line of excavators. Frank is a newer project engineer who has not interacted much with Oily Hydraulics before, while Matt is a colleague working on the same project team. Hometown Machining is a trusted vendor of Oily Hydraulics who machines manifolds when Oily doesn't have sufficient capacity to machine them internally. Chanukah manages all requests for quotes and frequently engages Gavin to review and comment on designs from a machinist perspective. Note that all project workflows within Manifold Edge are initiated and controlled by an assigned project engineer, in this case, Carlo. After creating the project, Carlo assigns Mark as an internal reviewer and alerts him to check the design before he releases it to the customer or the vendor. Carlo also shares a review design to Frank as customer approver and Chanukah as a vendor reviewer. Frank and Chanukah can subsequently assign internal reviewers within their own company to also participate in the design review process. So given this context, I will introduce the Manifold Edge project engineer who has the design about ready to share for review and approval. Carlo?
Hello, John. Thank you. Thank you for the introduction. So as a design engineer today, I will start this workflow of design collaboration. Let me start from the standard documentation that we normally make when we need to share a manifold design with our customer or vendor. Usually the communication is made through some 2D drawings. So normally we try to make what we call layout drawing. So a drawing where we have a 2D manifold assembly view with dimension and hopefully with a schematic inside, but there are always some glitches with line style, line types, and this is a document that is nice to have, but always takes some time. For a web vendor, we need then to share a machining drawing, but every time really the machining drawing takes time, although it can be automated, and then there may be some changes. So you do some work that may require some rework. In other cases, you just share the schematic, and so you need to print it out. So I'm going to show you that this kind of documents can work as well in Manifold Edge, but we are trying to innovate. We are trying to share technical documentation for our manifold project in a different way that is more interactive and more powerful. So we'll start our demonstration, and I sign in into my Manifold Edge page. I belong to my Oily Hydraulics organization, so I have colleagues that I can see here in my internal users. And of course, I have reviewers, and later I will involve some reviewers for my project. I can manage customers. So now there is only this new company, GT&R Excavator, where I have Frank, my customer, and his colleague, Matt. And as you can see here, I have the possibility to specify what this customer can do. So the customer is allowed to download a step file. Normally, we try to give step files to some customer because they may need for their machine to check if it is fitting properly. Otherwise, if you don't trust, you just uncheck it. We can create a new customer and specify user for customer. And of course, we can manage vendors. So sometimes the company may have internal capacity to machine the manifolds, but in other situations, they may go outside. So this is the case. I will go outside to Hometown Machining. And with them, I'm going to share for sure the MBXML file and the step file. I'll allow them also to download because they may have a CAM software where they want the step file, or they may have MD tools as a design tool. So giving them the MBXML file allows them easier import and checking functionalities. Let me start with a project, and I will start with a new project. And I need to specify a project number. So that's my Manifold Edge 12 project. My revision is 0. I will provide a title to this project. So that's a Match Webinar. And I'm going to assign this project to my GT&R excavator and the approver, because this collaboration platform is supposed to share and get approval for a project. So my approver will be Frank. And then I will switch to the vendor, Hometown Machining, and I will specify that Chanakia is my person I'm going to talk to during my project. I can save my project. So now in my primary view, I can view all the projects with all the project status, reviewed, approved, and so on. But we go to the last project, the new one, and I will need an internal reviewer. So normally in our process in a company, in a structured company, we do a job, but we ask someone to check, double check, not because we are not good with our project, but because we need some validation layer. So my approver will be Mark, the manifold designer. In this case, Mark is not as capable as me with MD tools, but we will see that his interaction with the 3D model will be simplified thanks to the tool that we give him, so that he does not need any particular MD tools knowledge to take a look at my design. So I'll start my uploading. So I'll start uploading, and I can upload the standard files like the assembly file as a PDF. I can upload the circuit in a PDF format if needed. I could upload the machining drawing, and I can upload my circuit in DWG. This is smarter because we have a technology in the cloud that allows us to view. Actually, we have also technology to edit it. It's called a NetScheme, or declined in other application for instance, for Danfoss or other customer OEMs. So let me load the DWG file. Let me also load an MBXML file. We are all familiar with MBXML file. So basically from MD tools, when we have a block, we can easily generate an MBXML file just by saying export. And this will save our MBXML file for our design. But my MBXML file is ready, so I'll just upload it. And then I can upload my step file. Normally, you don't upload everything in one go. So you start maybe just with a circuit and you get approval from your customer. So the circuit I will share with Frank. And he wants to look at also at the assembly. So I will go to the assembly and give visibility to Frank for sure. Frank is not supposed to check how I make the block. So I don't want to give him visibility to the internal of the block. But let me, in the meantime, send an alert to Frank so that he knows that there is something going on, and he will get an email for that. But usually you don't do that. Usually you first ask approval internally. So let me send a communication to my internal reviewer, and I tell him, hey, Mark, please check the new design. And I send him an alert. So he's going to check. We don't have unlimited time today. So usually we send the project to our internal reviewer, he approves, and then we forward to our customer. Now I do everything in a row. I share my MBXML with the manufacturer because he needs to check how it is made. I want to share also the 2D drawing of the manifold assembly with Frank as well. And I want to share my, well, the circuit in PDF really is not needed. There is a circuit in DWG. And the machining drawing of the block, I will share as well with Shanakia. We'll see that it's nice to have, but really it is not needed for the purpose of checking our documentation. I can send alert to all people involved in this conversation. And of course, I can also send a direct communication to my vendor, to my internal reviewer if it is needed. I could also show you how this viewer look like, but let's see what is the point of view of the other participants to this workflow. So ideally, I make a design and I ask for an internal review. So now I turn it over to Mark, which is going to check my design.
Thank you, Carlo. I noticed I got a manifold edge notice here. He asked me to review. I'm going to review this. I'm going to go to manifold edge. And as the internal reviewer, I'm going to see what Carlo has done. So I see I have a block and I have a circuit. So I'm going to look at the DWG first, which is in it's an AutoCAD file. Okay, I see that I have 3 solenoid valves. I have a pressure reducing valve. There are 2 counterbalance valves. There's a relief valve, and there is a small orifice. So let's look at the manifold, because that's what I'm interested in. And I can see the manifold, and I can zoom in. I'm going to check a couple of the distance between 2 cavities. I see that's 32 millimeters. That's fine. I notice the orifice is right here, the orifice plug. So I'm going to check the location of that. That looks fine. I can also, if I want to look at just that face, I can eliminate all the other internals and just look at this face. I can turn on all the dimensions if I like. And I can look at that, but mainly as an internal reviewer, I'm interested in looking at the schematic versus the block and just make sure everything's correct and make sure it all jives. And usually I would check this 6 ways to Sunday, but for the purposes of today, I'm just going to check a couple of nets. Nets are networks, in case you didn't know. I'm just going to check these 2 pilot lines. So I'm going to go back to the manifold, and I'm going to go over to nets. I'm going to check this first one. I see we have a, this goes from this A port to the number 2 port here, the number 3 port here, which is the pilot. That looks good. And then the other one, I see it goes from the B port to the 2 and to the 3. And with just 2 drills, you can't get any easier than that, any simpler. This looks really good. So I'm going to tell Carlo. Looks good. I'm going to go back to projects. I'm going to send an alert so Carlo knows it's good. And I'm also going to mark it as reviewed because I'm satisfied by this block. This is great. I'm going to turn this back over to Frank, the customer.
Thank you, Mark. So as a customer, I'm going to check out the assembly and I'm going to make sure that it works for within our machine. It is fitting. So see that I got an email from Carlo stating that he shared some files with me. So I'm going to go into Manifold Edge. And I've seen this circuit before, so I'm just going to skip right to the assembly. And I can see the entire assembly based on what he shared. And so I'm going to start by looking at the dimensions of the block using one of the commands up here. See, we have 195 by 100 by 85. I should probably pull up my spec sheet so that way I can share that we need a 250 by 250 with a 450 millimeter depth. Those are maximums, so we cannot go over any of that. So it looks like the block is within those specifications. And I did share with Carlo that I want our pressure and tank lens on opposing sides, preferably the left and right, and it looks like he met those requirements. So let's check the height with our show port location command. And it looks like they're at the same height. That's great. I love that. Keeps my plumbing all organized. So we can turn those off now. And now, just to make sure that it actually fits within the entire section, let's check the entire assembly dimensions with this command. And it looks like neither of these go over that 250 that I had mentioned, and our depth is just 250, which is very short of our 450 millimeters that we had mentioned before. So let's turn those off. Now I am seeing this sunken counterbore with this counterbalance valve. So I am going to have to alert Carlo. So let's go to the project owner communication and let's let Carlo know. Carlo, please share the clearance between the hex head and sunken counterbore for servicing. And we're going to send it. So now if we go back to our project, here is the project page. And as you can see, I left a comment in the assembly and it leaves with reference to the assembly right here. So that way he knows that I am referencing the assembly here within the project page. And I'm going to send an alert so that way he sees my message. Now I do want to share it with somebody within my company. So I had Carlos set up the account for Matt and I'm going to share it with him. And then I'm going to leave Matt a message. So within the internal review, Matt, please inspect the assembly. I'm going to hit send, and then I'm going to send the alert. Now Matt should be able to see everything, and only Matt will see this comment. So Carlo shouldn't be able to see anything between the two of us. And just so that I have everything within the project and it's all organized, I'm going to upload our spec sheet. And then we have the whole project in one spot. And I'm going to take a look at our 2D assembly drawings. So I can pan. And I mean, this is very clear, very neat. I really do like this, but I probably in the future will look at my assembly mostly. So I think I'm going to leave it up to Matt and we will talk about this. But for now, I'm going to turn it over to Janika, who is going to talk about the vendor quote manager. Janika?
Yep, thank you, Frank. So being the owner of Hometown Machining, I've just received the email from Carlo, who's the designer at Oily Hydraulics. And I can click on the project, the email here to view the files. And I'm going to log into Manifold Edge. So once I log in, I can see that Carlo has shared with me the block and the 2D machining drawing as well. So first, let me look at the machining drawing, which is what most machinists would look at first. And I can zoom in, look at all the information here. So this is the machining callouts that's been added here. There looks like there's some angled holes, which is the direction of the angle hole that's showing up here. All the cavities are all dimensioned on the views here. I can also so I see that he's also shared the block with me. But before I open up the block, I would like to share this project with my machinist, Gavin, also. So I'm going to add him as the internal reviewer. and Gavin, so that he will be notified of this project as well. Now I'm going to open up the block. So when I was previously looking at the 2D drawing, it was very hard for me to determine what the block depths are and what the connections would look like from the 2D drawing. But with this manifold internal viewer, it gives me more confidence on what kind of connections are being made in this block and what is and how exactly this block needs to be machined. So a couple of things I would look for is like what's the dimensions of the block. I see this is the raw stock dimensions that I would like the finished dimensions of the block to be 189 in the length dimension. So I would like to check with Gavin if that's possible to machine it to that dimension. So I'm going to go to the internal reviewer communication channel here, and I'm going to post a comment to Gavin to ask him to if he can machine it to Gavin. Can you machine Gavin 189 mm? And I'm going to send that comment to Gavin. I also see that there are some angled holes on the block here. You can, if I rotate it to the top view, I can see this angle plug looks pretty good. There's no interference anywhere. There are also some other angled holes like on the DO3 pad here, and this one here, this one here. So there are a couple of angled holes which look good to be machined. Should not be any issue with those. One thing that I would like to see is that the connection between the T1 and the T, I would like to see it somewhere in the middle of the block, just like I observed on the other end with the pressure ports, the PMP1. So for that, I'm going to post a comment to Carlo to submit, basically re-upload a design that has the connections for the tank ports in the middle of the block. So I'm going to go to the project owner channel now, and I'm going to put a comment to Carlo. Carlo, like P1 and P. I'm going to send that comment to Carlo. Other than that, rest of the block looks pretty good. Should not have any issues with machining this block. So I'm going to now go back to the projects page, and I'm going to send those alerts that messages that I posted, and I'm going to let Gavin take over now and explain his feedback.
All right, thank you, Chanika. So as you can see here, as the machinist, I receive an email in my inbox letting me know that I've been assigned to the project, and also here I got another email letting me know that Chanika left a comment to me directly. So if I go here to Manifold Edge, I can select the project here, and as previously seen, I can see the MBXML here and the actual machining drawing as well. So the first thing that I will do is view the MBXML to see the machinability. All right, so here we can see that I have a comment from Chanika, and he says, Gavin, can you machine the length to 189 millimeters? So it's currently 195 millimeters in length. And if I am just looking at the block here, I can determine that that is definitely something I should be able to do if I just shorten this length a little bit at certain points here. So I'm actually going to let him know now, Chanika, it is okay to machine this block at 189 millimeters. So I'm going to send that comment to Chanika now. Now from here, I can use several of the other tools that we have available as a machinist to see exactly how I can machine this and kind of lay out a plan of action for it. So one really useful thing here is if I use the Display Machining IDs tool, the face that I'm viewing, it shows me all of the machining IDs so I can keep track of them, and it'll make it easier in the long run for when I actually get to the machining point. When I rotate the block around here, whichever face is closest to me, it shows me the machining IDs for those. Now regarding machining, again, one thing you can also do is you can display the machining sequence. So if you select that button and then select one of these cavities, it allows me to see the counterbore diameter in depth and then also the final step diameter in depth. So it kind of helps me plan for what drills I'm going to need to use and make the plan in the long run for it. Now, another really useful thing here as a machinist is I have the option to display all cavity locations on a single face. And if I turn on dimension each cavity in a footprint, it shows me the specific dimensions for every single cavity that is on this face, even like individually for each footprint. Now, this is very useful as a machinist because it allows me to see the exact details of where everything is, and I know how to program my machine and set up my drills and all of that. And if you hit escape, it exits that tool. Another useful feature here is if you go to the cavity browser and you select the block, you can hide all cavities within the manifold. And say I specifically wanted to look at this B2 cavity, I can just simply select that to view it, and now I can just see this by itself. Now you can do this for multiple cavities at a time. So say I just wanted to see these three here, I can look at those alone without all the distractions of all of the rest of them. And to get all of them back, you just simply click this button again and they are all back to normal. Now, another very useful tool as a machinist is the display intersection details. So for example, in this situation, there is an offset hole right here. And if I want to see the exact details of it and not have to worry about any drill wander and make sure I can plan for it properly, I selected the tool. Now I select this cavity and this cavity, and it shows me some information regarding the two cavities and their intersection. So it shows me the end depth, the start depth, and the offset. So I can plan for that with my drilling process and everything should be all set. Now, as a machinist, another major thing that I want to look for is angle holes and whether or not I can actually machine them with the tools I have at my disposal. So if I use the angle hole command and I select an angle hole, it'll show me the exact alpha and beta angles of the cavity itself, so I can determine if that's machinable with my machine. So I can see that it's 10 degrees and that it should be perfect for my machine, so that won't be any issue at all. Now, lastly, another very useful tool is you can measure the wall thickness. So for example, say I wanted to find the wall thickness between this cavity and this cavity here. It displays the wall thickness there in the millimeters, so 20.79, so that's obviously no issue at all. And that's just very useful. Say, if we have a certain tolerance that the wall thickness has to be, I can look for different discrepancies within that and make sure that none actually appear in the final machining. So I'm going to leave one more comment for Chanaka. Chanaka, this block is all set to machine and has been reviewed. So I send that back to Chanaka, and then once again, I'm going to go back to my projects. We'll send the alert, and then I will turn this back to Chanaka.
Okay, thank you, Gavin. So as you can see, the Gavin's comment is just shown up here, and it says everything looks good. So the next step that I would do is I would probably upload a code so I can send this off to Carlo. So I'm just going to go to and pick a code that I want to upload to, and once I upload the code, I can, if you want to view it, you can double click on it also and to view the code in details. So now I can go back to the projects and I can go to the project owner communication, and I'm then going to post a comment to Carlo to ask him to review the codes. And I'm going to send that. I'm going to send the alert. So now, once I'm done with all the inspection, I can now mark this project as reviewed because everything looks good, and I'm going to click on mark reviewed. So now the status shows it's been reviewed, and now I can hand it over to Carlo to continue with the presentation.
So as you have seen, we keep, and I am the final loop of this trip around different people, participants to this design workflow. We interacted through a cloud platform, and we receive notification by email about something that is happening. So now I see that Chanaka has sent me some comments, so we can go there. But all the information regarding the project will stay in a common space where everything is accessible and is ready to be used. I can filter by communication, so I can filter my vendor communication. I can see that Chanaka has reviewed my design, and I can also go to the project status, and I see that Frank, which is the final end user, has not yet reviewed. So I, of course, can send him a note and say, hey, Frank, does the manifold look good? Good. So that he can approve. And later this will turn to green when it is reviewed. If I go back to the vendor comments, I can see that there is a comment about the design in the context of the MBXML viewer. So if I go directly to the MBXML, I will see the comments related to that particular aspect. Mark is confirmed that the project is good, and Chanaka is saying that I could split T and T1 drill. So it is very easy to do some to upload to make a revision from here. So we can go to the project and create a new revision, and we make a new revision 1 and save it. By default, the revision will keep the same files that were belonging to the previous revision. So we can just apply, upload the files that needs to be changed. And for us, it is basically the block. So I can go back to MD Tools and check the, let me check the block width. It is 195. So let me make this drill. I make it 97. And I use match properties to copy the same drill depth, and let me apply the same depth also to the other drill. And I copy the drill depth. This change will not have any impact with my final assembly, so I don't need to do again a drawing and so on. I will just export this one. And of course, I can share again with all the participants. I can view it on my own and can verify that now the depth are correct according to the needs of my machining. So this presentation is going to the end. So we have seen all the different interaction across designer, reviewer, vendor, and customer. So I turn it over to John for some additional comments.
Thank you, Carlo. I hope today this demonstration provides you with a greater insight and appreciation for how Manifold Edge fosters collaboration throughout the entire Manifold design lifecycle. So you saw where assigned reviewers and approvers do not require access to any CAD software to fully inspect the Manifold design. Also, they do not need to have CAD software experience to use Manifold Edge viewers. So the inspection experience is designed to be intuitive. The viewers were specifically designed specifically for inspecting manifolds, so it makes it a little bit easier to focus just in that area.